Okay, I made it, I guess.
All right, I heard you. I heard you say you made it. Okay, I apologize for that. But you're in here. So Rylan, I just barely started talking about stuff. You haven't missed hardly anything. Just all of the important stuff is what you've missed. So otherwise you're good. I will, and I do have this, believe I am capturing it. So I will get it uploaded to Moodle as well. So you will see the first bit that you missed. You're not being left out too much. Okay. So real quickly, I would like to spend just a minute as we get started here. I'd like to spend just a minute going around with some introductions. I'd like to know who you are, what your major is, and what else would I like to know? How about a favorite pathogen? That's a good one. Oh man, if you don't have one, you better think quick. All right, let's start with Michael.
All right, I'm Michael, microbiology major. My favorite pathogen, I don't know the name of it, but it's the one that causes MERS, the camel one.
Oh, okay. Okay.
Ebola is a close second.
Ebola is a close second. All right. All right. Ebola is a good one. A little disturbing, but good. Okay, next.
I'm Casey. I'm a micro.
Not yet.
Not yet, no. My name's Kira. I'm a health science major. My favorite pathogen is the HPV virus.
Okay.
And it's specifically the one that causes it to grow on the skin, and they call them like the tree man syndrome.
Oh yeah.
And there's all these gross, like it like takes over your body, like your skin, and there's all these gross, and it is so cool, but it's so gross.
I was gonna say, is it gross or is it cool? Right? It's both.
I'm with Joe. I'm also my manager.
Okay. No favorites yet. Okay. You,
Okay.
Macy.
I'm Macy. I'm a microbiology major. I'd have to say rabies.
Rabies.
Fascinating.
Okay. All right. I like it.
I'm Tristan. I'm also a micro major, and I don't think I have a favorite pathogen yet either.
Okay. All right.
I'm Crystal. I am a micro major, and my favorite pathogen is Streptococcus pneumoniae, which is what I'm actually studying right now in summer.
Okay. You're doing some undergrad research with her?
Mhm.
Awesome. Awesome. H. pylori. All right, I'm going to flip this monitor around, Ryland, because they don't even know you're here. I don't know if it's.
All right. All right, so I'm Ryden. I'm a biochemistry major, and I'd have to say my favorite pathogen flip-flops every week, but right now it is C. diff, like Clostridioides difficile, I think it's officially called. But could you unmute real quick? Sorry, you're muted on Zoom.
You were hearing it before though, weren't you?
Yeah, you muted when the screen flipped, I think, so.
Oh, when I turned it, it muted. Oh, my owl tipped over. Maybe that's, there's a mute thing right on there. That's probably what happened. My crazy owl muted. That's all right. Okay, what I was saying was you're only seeing my torso because the camera is all messed up. It wants to give a panoramic view of the lab so it can see you guys, all right? And that's what you get. I'm not sharing stuff right now because I don't really have a lot of stuff that we want to share that way in the first place. But if we progress through here and we do have some high flex needs, we will get more of that set up. There, you can see the chalkboard. So if I start working with some of that stuff, hopefully that will be visible. If I had a projector in here, it'd be different and we could maybe be working things all together, but we don't. We're bare bones, right? That's okay. So we did not really, we met Wednesday, but we really didn't do much because we were only about 50% here, and that's all good. So the very first lab, I want to talk about it briefly, and I want to talk about what we're thinking about for this week. And today is just going to be thinking, all right? And then we will do stuff. Here we are, really week 2, but first lab is how I feel. We're already having to kind of modify the schedule just the littlest bit. We're going to do things a little bit different. It's all going to work out, right? But I want to kind of put the brakes on and just make sure we're all up to speed. So I started off talking about a little bit about pathogens, and I got a few the potential favorites from some of you. And others that just are too scared to really tell me that it is Ebola, right? That's okay, right? Or, you know, I had a student a couple of semesters back, and I don't know what the deal was, but he was fascinated with syphilis. That was his favorite, right? And wanted to talk about it all of the time, right? I don't know why, right? Some of those things I find a little bit more disturbing, and I'm like, you know, I kind of feel like I ought to wash my hands, right? I don't know, right? So there's all sorts of possibilities, right? As we think about pathogenic micro, it could be virus, right? There's all sorts of good, crazy virus that maybe you think of. When we are in here, most of what we're going to think about are going to be bacteria, right? Really, that's what we're doing in here is some classical micro to try to understand and maybe get a little more insight into some of the ways that we can grow these pathogens and identify, right? But with that said, there are numerous others like virus or a plethora of different protozoal or even worms for that matter that I'm just like, oh my God, I love them, right? I want to know more, right? But that's really not what we're going to do in here, all right? We are not going to collect fecal samples and weed through them hoping that somebody's got Giardia or hoping they don't, but deep down you hope they do, right? But we're not going to do that, all right? We could, but I think we probably shouldn't, all right?
He's got some great worm pictures.
I do have some good worm pictures, none that were my own personal worms, all right? But trust me, if they were, I would show and tell. So the first lab, and I don't have a manual that I have posted because this semester I want to do things the littlest bit differently. And the lab manual that we have been using for Patho Micro is pretty old. It is something that was put together by a couple of grad students. And then as I was a grad student and started teaching this lab, I modified it, tweaked it a little bit, and my name ended up on the manual. I didn't write it, right? But I made some modifications. And as I look at it now, I'm like, there's definitely some more things that should be shifted up with it a bit. I'm going to give you some of those details, but I'm not just going to post the manual and expect that that's all we're going to be rolling with. So I don't want to put it on there right now because I feel like we've got other things we want to think about. All right. The very first lab is supposed to kind of get you thinking about microbiology, get you thinking about a favorite, not that you need to pick favorites, but something that you find kind of interesting that you'd like to maybe do a little more digging with and find out some information. We have made it so that it's been a bigger project and you spend more time and then you put together a big written paper and a PowerPoint or something like that to present it. I don't want it to be a big headache like that. I want it to be something where you just spend a little bit of time and I guess kind of geek out a little bit. All right, just kind of think about it a little bit, find some fun facts, some interesting details, maybe some statistics, data like, how many people are plagued with this disease or get rabies or whatever it might be that you find interesting, right? And we're going to share that with the class. I don't want a paper to present all of this stuff. I just want you to put something together that quickly, it could be a PowerPoint or something like that. Just a few slides, a handful of things that you just share just the littlest bit about some of this. We will start thinking about it. I'd like you to start thinking about it. The couple that were here last week got my quick spiel of, oh, we want to think about a favorite organism. I don't know if you actually did.
I totally remember you talking about it.
You remember me talking about it? Okay.
100%.
And that's how this stuff works, right? It's in one ear and out the other. That's okay. I know how it works. I've got kids, right?
I think it's kind of blurry.
I know how this works. Okay. So in the near future, start thinking about it right now, but in the near future, we will have a lab where there's going to be a little bit of downtime, and I'm going to let you know soon when this is all going to happen. But I feel like during that lab, or maybe over the course of 2 lab periods, we will spend a portion of it where you just quickly talk about your stuff, all right? Just a few minutes, right, to share those details and think about things that are, maybe a little bit different. We definitely aren't going to play with or look at rabies in this lab. So learning some details about rabies, I think, is going to be interesting, right? Or MERS, or Ebola, or syphilis, right? Thankfully, we are not playing with syphilis in this lab, right?
MERS is pretty easy to not get. You just have to not kiss camels.
Well, I mean, is that easy? Rick?
Apparently not.
I don't know, right? If you saw one, you'd want to.
Apparently for South Korean tourists in Kuwait, it's really hard.
They want to kiss them. Yeah, I don't know. So that's the plan for this first lab. That's what's listed on the schedule of events, lab 1, and that's really what it is. I will post a little bit of detail about that. I wanted to wait till everybody was here and I said a bunch of stuff before I, obviously I'm not friends with Moodle. I say I'm putting stuff on there and I never do. I will get stuff posted, all right? I also realized I posted a Zoom HiFlex thing on the Moodle page, and then I just shared with you a completely different Zoom link. You are welcome. Because I don't know what I'm doing, all right? I posted all of these Zoom links the other day because I was like, oh, we should do this. Whatever, right? It doesn't matter. I've got everybody captive as I need. So there will be details about lab 1 that I post on the Moodle. It gives you a little bit of a kind of an overview, sort of a actual assignment, if you will. The next bit that we want to think about, what's scheduled for today, are 2 labs that are kind of slammed together because they should be. Staining stuff is one of the first things we think about when we're doing microbiology, right? It depends on what lab you are in, all right? If you're taking general or intro micro, staining is something that happens a few labs down the road, and it only happens occasionally. And there you go. You've seen it a couple of times, and we expect you know what's going on. That's not really true, right? My gut tells me it's been a while since people have done gram stains. In some instances, it maybe has been a long while, all right? There are always some opportunities when someone is sitting in class and they're like, I've never done this at all, right? And I'm like, what are you doing in pathogenic micro, right? How did you get to this point, right? It's like you've slipped through the cracks. You've never learned how to read, right? But you've been passed along, right? No child left behind. We've passed you along, and now we recognize it, right? You can't read? How did you get to college? How did you get into Patho Micro, right? I don't want to make jokes about that because it's not a joking matter, right? But I feel that sometimes I'm like, you've never gram stained? What the hell are you doing in here, right? We're going to think about gram staining, all right? And unlike other labs where you do it once or twice, you're going to do it once or twice every lab is kind of how it works, all right? We're going to do lots of gram staining. Almost every single time we come into lab, we're probably going to do a gram stain, all right? And see what's up. You're going to get cultures from me, and you're going to gram stain them. You're going to figure out what sorts of stuff is in there. Lots of times, the first few times, it's going to be just a single thing. But after that, lots of times, you should expect the test tube you're given has more than one thing in there, all right? That makes it fun, right? That makes it kind of more real world. And then you need to figure out what is it that's in there and what is it that's in there that I truly want to figure out, right? Some of those things should be there, like normal flora, and others shouldn't, like your possible pathogen, right? And we'll move through this, and hopefully that gets a little more, get a little more familiarized with it and know, all right? Then we'll grow things up, and maybe we've got multiple things on those plates. Well, we want to know what they are, and it's highly likely we'll gram stain both of them or all of them so we can see what's up and know a little more about it, all right? And replate and restain. We'll see this over and over, all right? So getting some skills with these techniques are important, and the repetition helps to solidify it, all right? Lots of gram staining, lots of streaking for isolation, lots of plating techniques that in turn, we hopefully move through here and we're like, okay, I can do this, right? I feel better about it. I feel more confident. And I hope as we move through here that that's really something we're able to work on, is, you know, building that confidence. So when you see a bunch of different plates, you can look at them and have at least a hint of an idea of what might be growing on there or why those reactions that you're seeing might be occurring, all right? That's what we hope. And so there'll be quite a bit of stuff that it seems maybe redundant or repetitive, and some of it at the very start is going to seem like you've already done this in some other labs, all right? Because you should have, right? I hope you've gram stained, all right? So the exercise 2 or lab 2 and lab 3 takes all of the staining ideas and tries to kind of consolidate stuff. Gram stain is one of the first things we think about, and typically the first procedure that we do. There are other staining techniques, but really gram stain is kind of the standard, right? There are other opportunities, depends on the circumstances, but maybe we see something that looks like it's possibly forming spores. You can potentially get some hints of this with a gram stain, and you might see an organism that looks like it's got a hollow bit inside of it, and that maybe, hopefully, raises a flag that this organism is a possible spore former, all right? An endospore stain will help us to solidify that as the spore picks up the pigment, and we're able to say, yes, it is a spore, right? There's some other bacteria that might form some inclusion bodies inside under a gram stain. It might be mistaken as a potential spore. It looks like just a hollow little circle. And doing a spore stain, those don't pick up the stain, and then you could differentiate that, right? Usually, you kind of get a pretty good feel just based off of a gram stain, right? When we think of spore formers, we think of gram-positive rods as potentials. So if you're looking at some positive cocci and it looks like spores in there, pretty sure you're not seeing spores, right? So there are a few things that already kind of target how we're thinking about that, right? Another specialized stain would be the acid-fast stain. And this staining procedure is something that we utilize, again, after a gram stain, but this is a different situation. And we think probably something like tuberculosis. So a patient comes in and presents with pneumonia-like symptoms. We collect a sputum specimen from this individual. That sputum specimen gets stained before we do any cultivation. We're going to stain specimens up to see what's going on, and then we try to grow them, all right? So off of the sputum specimen, a gram stain shows no reaction, but they have obvious pulmonary infection. All signs are pointing to some sort of bacterial culprit, but the gram stain shows nothing. That should raise another flag. Our friend Mycobacterium should not, if it's a good culture, shouldn't pick up a gram stain. If it's really old, that's a different story. But if it's active culture from that patient or specimen from that patient, it shouldn't be something that's super old. It should be fresh, right? And that typically doesn't pick up a gram stain. When we do an acid-fast stain, that's when it shows up, and we see these acid-fast bacilli, and can say pretty much with certainty this individual has TB, right? Tuberculosis is one of the only bacterial infections that we can ID and start treatment just based off of that staining reaction. You gram stain something and you can't say, oh, that's anthrax, or that's, Staph aureus, or whatever it is. You might have the hint that it's Staphylococcus. You might have the hint that it's a type of bacillus, but you really don't know that it's anthrax or that it's aureus or whoever it is, not just by a gram stain, right? But acid-fast staining is a little bit different, right? So those are the three. There are other staining techniques that we might think about employing, but those are the three main things, all right? And deep down, really, it's the gram stain that's important, all right? And that's more what I want to focus on, all right? We have potentials for some endospore and some acid-fast, but I want to focus right now on thinking about gram stain, all right? So there's lots of stuff with the gram stain, and I'm going to write up here. I cannot guarantee that you're going to see that stuff on my chalkboard or not, but the gram stain, little historical stuff about it, and I'm sure you can Google this up and see details and probably better information than I'm going to spew out, shoot from the hip, right from the top of my head. Gram stain was developed in the late 1800s, 1880 something. You don't need to remember dates, not in here, all right? Late 1880s, all right? Hans Christian Gram, gram stain, right? He was the physician, the scientist that developed this staining procedure, right? There are all sorts of crazy things when it comes to micro that I'm like, how did you figure these things out? Who knew, right? How did you know to grow something on that, right? All sorts of crazy types of media, different weird staining formulations that makes things show up or doesn't, whatever it is, right? So Graham wanted to visualize cells, and he was thinking about pneumonia stuff. I think Streptococcus pneumoniae was what he was really trying to see, but pulmonary infections, right? That's what he wants to look at. Robert Koch had already come up with staining procedures, the acid-fast stain, which I looked through some of this earlier today, and I was like, oh, that's a little bit different than I thought. I thought gram stain was around before acid-fast staining, but that's not the case, right? Acid-fast a little bit beforehand, and then gram stain afterward, which is a whole other story in and of itself, all right? So we already had the ability to visualize some cells, all right? We have the ability to visualize other cells like eukaryotic cells with some other staining techniques, but bacteria, it's a little bit different, all right? And some of these staining techniques really didn't lend to their potential to be captured very easily. So bacterial cells and eukaryotic cells are very different. They're considerably smaller. They have cell walls, and eukaryotics, it depends on eukaryote, but animal cells like our own body cells don't have cell walls, right? So the way these things stain are definitely going to be different, and the procedures that you use different, right? So trying to visualize some of these culprits was a task in and of itself. Trying to grow them was a completely different story, right? That was a whole other headache, right? So Graham wants to visualize some of these pneumonia-causing bacteria. Robert Koch already had shown some potentials for visualizing other culprits for pulmonary infections, finding tuberculosis, all right? So he starts messing around with all of these different reagents, all of these different types of dyes. Gram stain is something that we say is differential. It gives us the opportunity to tell the difference, differential, to tell the difference between types of bacteria, all right? And we know now, and we call these things gram positives and gram negatives based off of Christian Graham in the first place. He's the one that ultimately lent to the ability to discern these types of cells, all right? So there are numerous procedures, numerous steps in the procedure. There's not numerous procedures. There's numerous steps in this procedure to visualize these organisms. And again, it's different than looking at eukaryotic stuff, all right? Because we're talking cell walls, all right? So we set up a series, and there's all sorts of different lab manuals that give you slightly different steps in the procedure. You're still adding the same reagents, but timing might be the littlest bit different, all right? This isn't rocket science. It's not a exact science. You don't have to stare at the clock and let it go for exactly 60 seconds, right? It's a ballpark, right? About a minute, right? There are critical bits like the addition of alcohol. You want to be very cautious with that. But other stuff, you don't need to watch the clock, all right? So in order to visualize and to differentiate these cells, a series of different staining reagents are added in a kind of a stepwise approach to the slide, all right? And before we get to staining, we need to think about the slide itself, all right? In order to get those organisms onto the slide, we need to make a smear. So we take from liquid or from solid media a bit of organism and add it to the glass slide, all right? If it is something coming from a broth, I recommend 3 or 4 loopfuls of that bacteria added to the slide, all right? If it's coming off of a petri dish, a single loopful of bacteria is going to be sufficient, and not a humongous visible glob on that loop, all right? Just a bit, you can see it, but not a huge quantity, all right? In either case, you add the broth to the slide, you mix it around the littlest bit, you add the solid bit of bacteria with a small drop on the loop of water, and you mix it together, creating kind of another broth in that case. You allow that slide to air dry so that the bacteria sort of sticks to the slide, and then we heat fix it. We pass it through the flame 2 or 3 times till it kind of feel the heat on your fingertips. I like to hold it in my finger to know that it's not getting overheated. And I could kind of feel the heat to know that it's not, I'm not just leaving it on the bench top. It's not just cold, all right? The organism, as it heat fixes, it causes those cells to kind of glue themselves down onto the slide and adhere better, all right? There could still be a little bit that gets rinsed off, but for the most part, they get stuck to the slide, all right? At this point, and pretty much everything we're gonna work with in here, we're gonna make a smear, we're gonna heat fix it, and then we will go through staining procedures, all right? We're not working with any mycoplasma. Mycoplasma is an oddball. It doesn't have a cell wall. It wouldn't pick up a Gram reaction because there's no cell wall, all right? You would do some negative staining in order to visualize it, and with it lacking a cell wall, heating it can definitely distort or destroy those shapes. So you would do things a little different. We're not going to get concerned about that, all right? So the Gram stain, we've made a smear, air dried, heat fixed, and the first thing we do, the first step is crystal violet. And all of the staining trays up at the top should have these reagents in there. If they don't, we will get all of that stuff and get it all fixed up, all right? The crystal violet gets added to the slide and you kind of flood it on there, all right? And it sits on the slide for about 1 minute, all right? After the crystal violet has been on there, and in the front of you guys, there's a trough. There should be a little glass rod that's a staining rack. Your slides will be on those trays or those racks. You can tilt the slide right over the trough, rinse it with a little bit of water. There's squirt bottles with water in them. You can rinse the slide with a little bit of water and then put it back down onto the rack. When you do the rinsing, you should rinse it. There's my slide. Here's where my smear is. And you should apply the water up above the smear, not right on it. Don't spray it onto the smear, above it, and gently let it kind of rinse it at an angle into the trough, all right? After you've stained it with crystal violet and then rinsed it with water, we come in, and so I'm not going to put the rinses in there. We come in with our next staining reagent, and it's called Gram's iodine. And those should, I think, all be in glass bottles up there, amber bottles. We've recognized some issues with some of the iodine leaching out the plastic and causing problems. So hopefully they're all in some glass bottles up there. The crystal violet is what we call the primary stain. It's also could be classified as a simple stain if all you did was stain with that one dye, all right? Then everything would look purple and we could see shapes and sizes, but it's all purple and you really don't differentiate, all right? But in the Gram reaction, it's just a primary stain. It's the first thing that's applied. And everything would look purple, negatives and positives alike, right? We rinse with some water and then we come in with the Gram's iodine. This goes on again for about a minute. And we call the iodine a mordant. Basically what the iodine and crystal violet do is they start to interact within the cell wall of that bacterium and they form a humongous complex. They cross-link with one another and they make a big complex that gets stuck in the cell wall of bacteria, right? But specifically in the Gram positives, because Gram positives have a humongous, thick cell wall, all right? And that's very easy for these stains to get in there and incorporate with one another, interact, and get stuck, all right? So the iodine interacts with the crystal violet. It goes on for about a minute. We tilt the slide, we rinse it with water. And then at this point, this is the critical step. we're going to decolorize, all right? So to decolorize, there's a handful of different ways that the decolorization process can occur. We use grams alcohol. It's 95% ethanol. ETOH is ethanol, all right? So the grams alcohol, there are a couple of different potentials, and it really, you know, it kind of maybe depends on where you're at as far as how some of the stuff is prepared. Sometimes it's got some acetone with it. Acetone is nail polish remover for those of you that have painted your nails. It acts similarly to the alcohol and helps to pull some stain out, as it kind of implies removing your nail polish, right? You would think that's probably pretty good at removing some color, right? So sometimes it's 95% alcohol and some acetone mixed together, different proportions. That might be lab, preference based off of it. There are others where they may mix some other substances, maybe some bicarbonate to kind of buffer it, not make it as acidic, all sorts of different things. Well, we just work with 95% alcohol, right? It's just that, no other additions. Some others, I think, even have isopropyl or rubbing alcohol in it. Yeah.
Is that a quick question? Do you rinse with water after the grams iodine?
Yes, after the I didn't put any of the, after every number, there is a water rinse, all right? So after the iodine, we rinse, then the decolorizer, and this is, as I was saying, this is where it's more critical. And lab manuals vary for sure when you look at the gram stain procedures. Some of them say a few seconds. Some of the stuff I've seen says 10 to 20 seconds, 20 to 30 seconds. Every time I see that, and times that are like pushing 30 seconds, that is way too much, right? It really kind of depends on your smear as far as how much alcohol is needed, and then deep down you question, is there ever too much alcohol? That's a different story, right? So the slide needs to be tilted, and the same idea as you're rinsing it with water, you're going to come in with the alcohol and squirt it above the smear. The alcohol is going to run down the slide, and I'm going to look at the bottom of my slide as it's dripping into the trough. As I hit the alcohol on there, the first bit I see is going to be some kind of blue. Then it gets a little lighter, kind of violet, crystal violet, right? I see that come off, and then it gets very light, and then it's gone. And I don't really see any more color. Typically, this stuff happens in a second or two, all right? It's not 20 seconds, all right? As soon as you squirt that alcohol on there, it's pulling the stain off, and you can definitely make a gram positive look negative if you put too much alcohol on there, all right? You can do the opposite if you barely put any alcohol on it and you don't decolorize it like you should. Now a negative looks positive, all right? So you do need to kind of know, and you need to watch, all right? Not just saying, I have to squirt it on there for 20 seconds and I'm watching the clock for 20 seconds to go by, because now I've pretty much over decolorized, all right? So I watch my smear, I watch the bottom of the slide as the stain is coming off, and as soon as I don't see any more color, all right? I don't care what the manual tells me. As soon as I don't see any more color, I grab my water bottle and I start to stop the decolorization process. Squirting water over the top stops the action of the alcohol, all right? At this point, it's still coming off clear, but now it's water that's running off of it, all right? And anything that should have been decolorized, you hope has, and you also hope that things that shouldn't, you didn't leave it on long enough for that to occur, all right? And we will go through these motions and see stuff. Some of you will have nice and purple looking positives. Some will be a little lighter, maybe a little too much alcohol. and the negatives, some will look nice and pink, and others will maybe look a little hint of purple as well, because they weren't quite decolorized like they should. This is all going to take time, and we're going to do lots and lots of staining, so you'll get a better feel for really what's happening and know what's up, all right? So we're very cautious with this. I'm not putting any time up in there because it's truly depends on what you're dealing with. Super thick smears are not what we want to be making when we're trying to stain stuff. It's very hard to see stuff. Super thin smears are also not what we want, because then it's really hard to find them because they're so sparse, right? A nice kind of cloudy smear, and this is also something that we'll get more practice with. So we know, oh, here's a better smear. This worked well. I'm going to do that next time, right? You get a better feel for it. And you also, if it is kind of thick, try to move toward the edge of that smear where it's a little more sparse. If it's really sparse, you try to focus it in toward the center of where you think you put that bacteria, and hopefully see stuff a little better. So at this point, after the decolorization, if we were to slap this guy on the microscope, the gram positives would show up. They would look purple. And the gram negatives, if there's any in the mix, the gram negatives should be colorless. You can maybe see the little hint of their cell walls, little ghost looking cells, but you can't really see them because there's no stain, right? If stuff worked properly. And at this point, this is really the differential bit. Once we've decolorized it, now we can see some differences, right? But we really can't see those negatives until we counter stain. And so the last step, so primary, the mordant, the decolorization, and then the counter stain. This we use a reddish pink dye called safranin. And so when safranin's added, and maybe that's spelled right, maybe it's not, we will see. I don't know. I'm not looking at the bottle. That's, if I had a red chalk, you'd know, right? So the safranin, this counter stain, really doesn't do much to the gram positives, because if you add pink to purple, you just get purple, right? It doesn't really change them. But the gram negatives that are now made colorless by the alcohol, they pick up that pink, and now they're easy to pick out. So in a mixed culture with positives and negatives, should be pretty easy to see a bunch of purple cells and a bunch of pink cells, and no, I've got a mixture of these, right? If you've decolorized stuff properly, you can tell the difference, right? This is the idea for the bulk of the labs that we will be performing. We're going to come in and do gram stains almost always, and I already mentioned that, and we will do confirmation stains after we've grown stuff up to see, does this truly match what we were thinking it should be matching, right? Based off of this stuff, all right, if we're thinking a clinical situation, and we'll move through these motions here real quickly, all right, based off of these gram reactions, if you are given a specimen, if I roll in here with a test tube and tell you to tell me what it is, the first thing you should think about is staining it up. But then you're probably going to think about, how am I going to grow it? What sorts of things would I put it on? Based off of a gram reaction, we may know this plate or that plate will help to separate and isolate these bacteria. Maybe we just want it to grow, and we will put it on just an enrichment plate that lets everything grow, and we get mass quantities. Sometimes we do both, all right? So that everything grows, and then a selective plate where we can do some weeding, and we can compare what's on my selective plate that, or what's not on my selective plate that is on the enriched plate, and vice versa, right? And figure some of those details out. Clinically, this is one of the first steps, and it guides you into what you're doing. And in our lab, it's going to be the same idea, where it's one of the first things we think about. We do this process, and that clues us into what we should be plating and other sorts of tests. All right. So that's the thought, all right? We are not going to stain today. We're going to take Friday and do some gram staining, right? I have bacteria grown up, but I want to switch it just the littlest bit, right? And we will spend some time staining on Friday. Friday, we were going to think about some culture media, but I want to hold that off and think about that on Wednesday, right? And so we will talk some more about that on Friday, how we're going to do some of that. I don't have everything figured out 100%, but with the culture media, I will tell you this. Usually, when we grow things up, the stockroom produces all of these plates. They don't grow them. They pour the plates, give them to us, we inoculate, grow the stuff up, all fine and good, all right? There's a lot of behind the scenes stuff that happens that I kind of feel like we sort of take some of that for granted, right? We don't know how to make plates. We don't know how to do that. We don't know how to run an autoclave. We should, right? I feel like these are things that probably would be good to know, right? So instead of and we're going to tell the stockroom we need all of these plates, and they're going to make most all of these plates for us. But this first go around, I think it's a little better that we get our feet wet and we get in there and actually see what's up. How do we pour these plates, right? It's definitely a project, all right? So I'm going to have for the media lab, our first bit, all right? We're gonna get some stuff, powdered media, and we will weigh it out on a balance. We will add it to some liquid, to some water. We will dissolve it. Almost everything that we have, some media doesn't need it, but almost everything, thinking bacteria growing stuff, needs to be boiled to dissolve it first and then autoclaved. Even though autoclaving is going to dissolve it, right? Most everything needs to get boiled first in order for it to be dissolved evenly, and then it gets autoclaved. Otherwise, you get a mess, right? It doesn't quite set up or gel like it should, all right? So I thought, because I'm not on the other side, right? I thought, geez, how fun would it be for all of these students to weigh out some media, to prepare it, to cook it, and to pour these plates. I think that sounds kind of fun, all right? I used to, many years ago, I worked in the stockroom. I poured plenty of plates, all right? I kind of liked it. I kind of thought it was cool, all right? That's what I would like to do with the first bit. We're not going to make all of our media. We're not going to do that. But I thought it would be good to at least have an experience doing that. And then we will rely on the stockroom to pump it out because they're very good at it. And that's what they're here for, right?
I never got to do that part.
Because they don't trust you, right?
Not yet.
After I'm done with you, you will, right?
I did learn how to use the autoclave.
Okay, see? So that's good. Okay, do you guys have questions for me?
Oh,
Yes,
in the syllabus, it mentions the lab notebook,
yes.
and I just wanted to know,
What- What you have is good. A spiral, that spiral notebook, one of these, whatever it is.
I wanted to return them in.
There is a potential, yes. So I told last week, I was like, if you're using a spiral notebook, just make it something that you're not using for another class, then you're okay. Were you hoping to use it for everything?
I am taking 3 labs and all 3 are this stuff.
Okay.
It's all good.
Are you,
I can take like scans and send them to my other lab because he doesn't need it.
okay. And I can tell you that if I do call for them, I'm gonna be quick. It's not like I'm gonna have it for a month. I don't want that to happen. I will call for them a little bit, but my lab is small. There's only 9 of us. Most of the time when a notebook check happens, it's going to happen while you are all still here and you will have the notebook to leave with, all right? The first one, maybe not. I might take it so I can be a little more thorough, but usually it's like this, and I look at it and I'm like, maybe you could improve your penmanship or something like that, right? I have to call you out on it because, man,
Is that a challenge?
it is a challenge. Deep down, when I looked at it, I'm like, I can read this just fine because that looks like my handwriting. It's all fine and good. You thought you got me, but I'm like, nope, I can read that. I can read that slop. But I will, oh, now here it is. I have tried to be a little better with that because I've had other feedback as well. Like, I can't read this, right? That makes no sense, right? So some sort of notebook, 3-ring, or like this guy, whatever it is, it matters not, all right? Other questions? Yes.
So do you want us to buy the lab manual or just,
No, there is no manual.
because it's listed in the syllabus or?
And but that's not something, it's never been for sale. I make no money off of this. It is something that we have either printed off and dished out, or I have posted it on Moodle. I have it as an electronic version, but I would like to just give you little bits of that rather than the actual manual. I will have in here plenty of manuals. There are color atlases, some other stuff, this big diagnostic micro. I like to call this the big book of knowledge. This sucker is full of details and lots of flow charts, right? In your manual, as we progress through here, there will be some stuff like biochemical tests. I think that's lab 5, right around there. These are things that we're going to kind of separate out, and people will do kind of a specific organism, but I would like to bring it back to the chalkboard and have a table built where we list off different things and potentially some flow charts that we can create based off of some of that as well. Some of you took micro, general, or intro and had an unknown and followed a flow chart that gave you most of the details. I would like some similar stuff that we're able to produce that will help us progress along as we move through and start thinking about some of the unknowns, because most of the semester, about half at least, will be thinking about some of these unknowns where a tube is truly unknown to you, right? The first bit, I will let you know, here's X, Y, and Z, stain them up and see what's up. But after that, here is this, right? I won't tell you who it is. And we'll go through those motions, all right? So I will have other things in here that you can use, and there's a couple of micro lab manuals over there as well. There are some things like that, but the manual that's posted on the syllabus, you don't need to worry about that. I will pick and choose specific bits of that I want to share with you.
Then will those be on Moodle for us to print out and bring, or will they just be here?
I'll have stuff on Moodle. I will post stuff on Moodle. And there are potentials that there will just be things in here as well that I hand out. But for the most part, I'll try to get things posted to Moodle, and I'll try to post it to Moodle quicker than the day before. Yes.
What is your policy on writing up procedures before getting to lab? Or would you prefer to wait for it?
That's a good question. And so I think some beforehand stuff is good. It depends on the specific lab. Some of it you may know a little bit ahead. And I also, would like to get things posted to Moodle in advance so you have that opportunity. Writing some stuff procedure-wise into the manual beforehand is just fine. And it's, to me, probably better. That means you've gone through it, looked at it, thought about it. So when you roll in here, you're ready to go. Rather than you're writing every single procedure out as I'm trying to spew out a bunch of nonsense, right? Not nonsense, right? This is a wealth of information you're getting from me, right? Did you say yes?
I did.
Oh, thank you. I can't tell with all the masks on, right? Other questions? No, nothing else? How about from home? You good? Okay. All right, guys. I think with that, I want to stop. All right. We will pick up with gram staining. We might do an acid fast or endospore. Endospore for sure could be an option. The acid fast, I don't know, and it never really works very well for me, so we will see. So Friday, we will stain. Rylan, I assume you're still out. You won't be here Friday. Is that true?
They said it was 5 days after symptoms, so I might be able to, but it depends if my symptoms get better or not.
If you're still feeling it, don't bring it to us. We'll make sure you're good to go. I assume you've done some gram staining at some point in your life.
Yeah, I've done a few in general labs. So.
Okay. Okay, so no worries. We'll make sure you're all good to go. All right, guys. Cheers.
A couple of weeks ago, I was at this house playing kind of a Halo party, and this guy, so there's me, guy who owns the house, third guy says, yeah, I'm on some weird antibiotics right now. Second guy's like, oh yeah, what for? He's like, I have tuberculosis. I mean, let's just kind of look at him like, he's like, oh, the doctor,
What?
doctor's like, he's like, the doctor said it's not contagious. The guy who owns the house was like, good, I was gonna ask why you're at my house when you have tuberculosis. Coronavirus.
Yeah, what the heck? You know, and there are definitely issues with TB if it's
There was an outbreak at my high school.
Oh my
I
gosh.
wish last semester.
crazy.
I'll see you done.
All right.
So both of us are in Food Micro.
Yes.
Dr. Sheridan was just planning on us coming here first on Fridays